Hello, welcome back. So for this problem, we are asked to count the number of rectangles in the given figure. So it's basically a rectangle, a grid of rectangles, a 4 by 4 grid of rectangles, except that the top right cell is missing. To answer this one, I sincerely hope you do not count individually because it's gonna take you some time. Of course, you can do some systematic way of counting. But for this video, I will discuss two solutions involving some um, combinatorics principles. For the first principle, let's first discuss the general case where there is no missing grid. So let's say this is the grid that we want. This is an M by M rectangular grid, which means there are M rows and M columns. So let's just generalize. Let's say that there are M rows and N columns. To make a rectangle, so for example, we pick this rectangle here, this rectangle here. Basically, what we are doing is we are choosing two sides. We are picking two vertical lines and two horizontal lines, which will enclose our rectangle. So for the number of columns, since there are basically 1, 2, 3, 4, 5, or in general there are n columns, basically there are n taken two ways, of counting or picking the vertical bars. That's n taken two for the bars. Similarly, for the vertical rows, we are choosing two rows out of. Oh, sorry, there are not m. This is n plus one. If there are m rows, then there would be m plus one choices for the horizontal bars. So there would be m plus one taken two um, choices for the horizontal bars. So this is also written as NC2 if you're more n plus one C2 if you're more comfortable with that. This one is m plus one C2 if you're more comfortable with that as well. Of course, we can simplify this as n plus one times n plus two. Sorry, n plus one times n over two. This one is m plus one times m over two. Now, to count the total, we just have to multiply n plus 1 taken 2 times n plus 1 taken 2. So in general, if you have n by m rectangular grid, the number of rectangle is n plus 1 taken 2 times m plus 1 taken 2. Or if you want the specific ones in terms of m and n, that's n plus 1 times n times m plus 1 times n all over 4. So this is the formula if you want to count the total number of rectangles if there are no missing um, grids in the rectangle. Okay, but that's not what we have here. What we have actually here is something that has a missing cell. So to count the number of rectangles, my idea here is to first count the total number of rectangles and then eventually subtract the number of rectangles that contains this missing grid here. Yes? Yes. So for this one, this is m equals 4. This one is n equals 4. So total is equal to 4 taken 2 times, 5 taken 2 because it's 4 m plus 1 and n plus 1. So that's going to give us 4 plus 1 taken 2 times 5 plus 1 taken 2. And 4 plus 1 taken 2 is 5 taken 2. Sorry, what am I doing? This is 4. So this is 5 taken 2. 5 taken 2 is simply equal to 10. 5 taken 2 is also equal to 10. So this is 100. So the total is 100. Is that clear? Clear, clear, clear? Okay, so the total is 100. Now, let's figure out how to count the rectangles that pass through or that contains this cell here. It's actually quite similar to our reason earlier. So to do that, we fix this side and this side. I mean, the rectangles that contain this cell must always contain this too. So basically now we're only looking at finding the number of bars or vertical bars that will enclose this one. So basically we're choosing from here, from here, from here, from here. So that's 4 taken 1, which is simply equal to 4. For this one, or for the horizontal bars, we're choosing from this 4 as well. That's 4 taken 1 as well. Therefore, the total number of exclusions, let's call that excluded, is equal to 4 times 4 equals 16. Okay? So the number of rectangles that you want equals 100 minus 16, or 84. Therefore, the answer that we're looking for is 84, and that's our final answer. So again, the trick here is to first count the total, assuming there are no missing rectangles, and then the next is to find the number of excluded rectangles. Is that clear? Clear, clear, clear? Okay, let's look at the second solution. The second solution, I'm not sure if you'll find this easier. Mm, I asked some of my friends about this, and I think this second solution is what they are more accustomed to doing and more comfortable to doing. So it might be what you like as well. So for this solution, basically what we want is to count first the number of rectangles here, and then the number of rectangles here, and then subtract the overlap. The overlap. Because the overlap is counted twice. One from this one, from this vertical one, and then the other one is from the horizontal one. You get it? So if you do that, what we do is, or what we have here is, for the first one, it's a 4 by 3 rectangle. So the total number of rectangles there is 4 plus 1. I don't want the green. Let's do the black. 4 plus 1 taken 2 times 3 plus 1 taken 2. So it's 5 taken 2 times 4 taken 2 is equal to 10 times um, 6 equals 60. So for the first case, the number of rectangles is 60. So if we look at the horizontal one, this is basically a 3 by 4, a 4 by 3 rectangle, but is rotated. So the number of cases for that one is also 60. You get it? So for this vertical one, there are 60 rectangles. For the horizontal one, there are 60 rectangles as well. So we're now left with um, counting for the overlap. For the overlap, we have this 3 by 3 rectangle. So the number of rectangles there is 3 plus 1 taken 2 times 3 plus 1 taken 2. It's 4 taken 2 times 4 taken 2, which is 6 times 6, or 36. Therefore, the total number of rectangles that we want is 60 for the vertical and 60 for the horizontal, minus the overlap, which is 36. That's 120 minus 36. That's 84. And that's similar to what we got earlier. So the second method is, I think, there's an argument to say that it's easier because you're only um, you're only using the same formula for the three of them. That's the m take m plus 1 taken 2 times m plus 1 taken 2 all over. So just have to account for the overlap. Personally, I prefer my first solution where I first counted the total and then subtracted the one that contains the missing grid. It's up to you what method you want. The good thing about both methods is that you can extend that for other situations. For example, if instead of one missing grid, there are two missing grids now. You can apply the same reasoning and you might be able to figure out the answer. Okay, so that's it for this problem. Thank you for watching and see you on the next one. If you have any questions, clarifications, don't hesitate to ask me in the comments. Okay, bye bye.